Hello guys, today I'll be sharing with you a design principle I created for concurrency. When a concurrent task becomes long running, for example, a data stream, it is important to watch out for unexpected failures. Now this principle I call AURA, Active Uplink Recovery Algorithm. Now the principle implies that a long running task should be self-aware and self-healing. Now, this means taking into account retry on failures, evaluate health of the task periodically, auto-reconnect, continue on recovery. So let's see how we can implement the aura principle. So to begin with, we have an extension function here called aura stream, and this is going to be launched within a coroutine scope, right? So this launches a coroutine, and this coroutine will be executed every 3 seconds as long as it is active. So we use the coroutine scope to monitor the state of the coroutine. Now, right here, we have our data stream where we are going to be pulling data from the stream. And if anything goes wrong, we have our retry method here that is going to retry the process, right? So how can this be implemented? So to begin with, we are going to create a function that we can call hello. And this function basically is going to be the function that pulls data from the stream. So we use a kotlin flow and we can use a random data type. Now this function is basically going to return a flow, and we are going to be emitting a random text. We can say hello there. Now to call this function, we are going to call it within a composable because this is Jetpack Compose. And so we are going to create launch effect, and we pass in the lifecycle owner. Now the lifecycle owner in this case is the component activity because this is the calling activity, right? So within our composable, we are going to be calling our data stream from a background thread, and we do that using dispatcher.io because this is a long running operation, right? And then we can go ahead and call our aura stream passing in the hello function. Now notice we are calling the aura extension function within a coroutine scope. Why? Because it is an extension function for the coroutine scope, right? So if we go ahead and launch this, so you see we are printing hello there every 3 seconds, right? Because this is going to be executed every 3 seconds, as you see here. So now let's go to our function here, that's our data stream, assuming that we are going to be emulating the fact that this data stream encountered an exception. So here we are going to throw an exception, and we can say something went wrong. So if we try this, and you can see we are printing something went wrong. So this is with an assumption that while pulling the data from the stream, something went wrong, and it keeps retrying that process every 3 seconds, right? So with this principle, you can implement a data stream in addition to a retry method that takes into account the state of the task, that's the concurrent task. I hope this helps. Thank you.